Welcome again to Embedded Journey. Last time we make a brief introduction to the topics of this little tutorial about IoT and Wi-Fi communication. So today we will be dealing with the esWifi library and esWifi module. We're gonna bring up the system, and at the end we're gonna make a little program in order for you to see what is going on and how to interact with the module. So get ready. First, you need STM-QMX. If you have the new version of the STM32Cube IDE. So start with accessing the board selector. Let's select our board. That's going to be the B-L475E-IOT-01A1. Okay. This is the QMX first window. So select the board and then select start the project. Okay. Go to the Inventec website so you can download all the documentation for the esWifi module ISM43362. ISM43362. So first things first. So we have the pinout of the chip that are dedicated to the ISM43362. Okay, we're looking for the data ready pin. This pin gonna be triggering an interrupt when data is ready and when it's ready to receive data. So it's pin E1. So we need to get that in mind, because later we're gonna set up the interrupt for that. We're gonna be, as it is pin 1, we're gonna be activating the XT1 interrupt in the chip. Also, the SPI3 is the communication module that we're going to be using from our silicon. Okay, so SPI3 needs to be activated in the same way. Also, SPI3 interrupt need to be activated. But first things first. So let's select first the type of project we're going to be using. Leave that on, generate on the root. Leave that on. Okay, it's going to be, it is better. Select your workspace where you're going to be working. I'm selecting an Embedded Journey workspace, and I'm going to give some name for this project. Let's say lesson 1. STM32. Just lesson 1. Lesson 1. Let's leave it as it is. Let's go back to the pinout. Okay, check everything. Leave generator on the root. Leave it check. Okay. If you want, you can check. You can change your heap size and your stack size. I'm changing this because in the future it's going to be a big library, and we don't want to get run out of space in the heap and on the stack. So let's verify everything that is on. Project manager. Check the clock that is set up properly. That'll be 80 megahertz. This is the maximum clock that is this chip allows. Okay, so in the pin configuration, go to connectivity and select SPI3. This is the user one. This is for our main console. Let's activate the global interrupt for our SPI3. Then let's go to the GPIO. Let's look for our data ready pin that we're using, ISM43362 data ready. Okay, it's going to be XT1, external interrupt 1. Let's activate that. Let's look for the pin E1. Here it is, E1. Let's select this. Check everything. And then go to NBIC, to the nested interrupt. Let's look for XT1, and then let's enable it. Okay, E1, perfect. So let's enable that pin. So when we generate the code, we have all the things that are related to that pin code generated. Okay. Remember, you must have some kind of knowledge about how to bring up a project and how to compile it. Okay. We have everything ready, so we are ready to generate the code. Let's do it. So the first time, let's generate the code and be sure that your project is STM32Cube is up in the proper workspace. Okay, because we don't want to mix up a project with other workspace. So it's up. Let's see. Here's the project properly generated, and let's see what the code says. These are our main code, main C. The SPI3 is there, but we're not going to use that function because the library has all the functions for the initialization required, as well as this this interrupt. We're only checking that everything is in place. So everything is in place. Very good. So right now, let's check for our project. Let's see the configurations. And again, let's go over here. It's 16 bits data wide, the word that's going to be transmitting. And it's going to be around, 20 megahertz or 10 megahertz. 20 megahertz the maximum, but we want to go to 10 megahertz to play safe. Okay, 10 megabits per second. So let's generate the code again. Again, don't open it, it's just open, just close this window and update your project. It's going to be updated automatically. We are not going to need the initialization because the library has its own initialization in place. So everything should be okay if you tells to the project that don't generate the code for that initialization. Go to the embedded journey repository and download the esWifi library. Okay, download it so we can include it in our project. Verify that everything is complete. Go on down and download it under this green button. Verify that everything is okay. You have several options, but what we're going to do is we're going to embedded journey. We're going to download the library per se. Download a zip file containing the library and then unzip it, and then copy or just link the folder to the project. This is the actual main file that was created. Let's import right now the esWifi library that we just downloaded from GitHub. Okay, so what I love to do is always link it, because sometimes I make changes to all the other libraries that I build, and I don't want it to be back and forth copying libraries from one project to the other. So what I do is I linked it. So let's examine the esWifi library first. Let's go to a low-level SPI communication interface that is already given by SCM32. Okay, this is not me. Okay, this is something that is included in the projects, the sample projects that comes with a board. Sometime in the future, I'm gonna tell you where they are, but right now let's cut to the chase and let's jump in directly. This is the callback functions for the ESPI, the transfer, the transmit, and the receive complete. This is the initialization for the SPI, actual SPI initialization. This is the one that we're going to use. This is the pinout configuration for all the GPIOs that we're going to use for the esWifi module, all of them, for the SPI and for the other pings that are involved in the communication. Particularly the data ready ping that is going to be used in the XC1 callback. Examine also the esWifi library, all the functions. Get familiar with it. I suggest that you go to the Inventec website and download the command PDF, the AT command PDF, so you understand what the commands are and what they do. Well, this is the interface context. Okay, this is like the native. All the information safe over there uh, for reference. Also, all the functions that will be needed to access the hardware in the module, the communication. And then lastly, the wrapper. Wi-Fi.c is the wrapper that is going on top of the esWifi library. It's simpler, it is intuitive, uh, it's an initialization. You call Wi-Fi init and it initializes everything, uh, the structures and the hardware. Okay, all the functions is referenced over there. They need delay and send data and receive data. Everything is referenced over there. So make sure that you understand these basic things for that wrapper. Okay, so let's verify that in the file of interrupts, we have the SPI interrupt function set up over there. And we're gonna make an external reference for the SPI handler that is in the low level library. Okay, so make that reference as external on the interrupt. Make sure that it's there. Okay, so make sure also that it points out to the HAL SPI interrupt handler. In the same way, the XT1 have the pin for the data ready pin in the chip. So go to the MX again and check out the code generation for SPI3 init. So we don't have it over there. So we don't have a double initialization. It may cause trouble in some ways, in some configurations. So make sure that it is not over there anymore. Generate the code and update your files. So make sure that everything is over there and the initialization is done in the low level file. So go to the repository and download this retarget library that gonna turn your UART1 into the STD out console. So the printf and all the print functions gonna be routed over there. It's included a printf library from that I got from other programmer. It is a re-entering library and it's RTOS safe. It's very light. It's not as heavy as the printf. I love using it. I tweak it a little bit. There are some things that I've done in the past to make it work better. So you have your EO get chart and EO put chart functions. They're going to be mapped to your write functions that is in the syscall.c file that is in your source core library. Okay, so we're going to be using first the Wi-Fi init, and we're going to be using also Wi-Fi connect in order to make the connection to the Wi-Fi network. I'm going to show you how you can do it, and we can wrap up this lesson for today. Okay, so go to your main file, main.c file, and write this code. Okay, first define a couple of variables in order to host your SSID and your password. Create a little buffer, 32 bytes is enough. Then call Wi-Fi init. Wi-Fi init will return a result code. All the functions that I'm using here, message error, and is a login system that I implemented, I have. So use it, okay? It's in the retarget file in the GitHub repository. Get module name is also a function that is in the wrapper, Wi-Fi wrapper, Wi-Fi.c. Wi-Fi.c wrapper. Okay, it's at the very end. Okay, get it over here. See what it does. Examine it. Go deep into it. Look, learn. Okay. Start using the functions that are there. The easiest function, the evident functions. If you want to go deeper, you can go. So right now we're going to be dealing with the Wi-Fi connect, get module ID, get module name, get IP address. All the functions that work without connecting and get IP need to be used after connections, because the IP address is coming from DHCP. Okay, get connected. Use this one, the number 3. It's the best one that worked for me. Look at the function, connect to the Wi-Fi, get the IP address, print the IP address, print the result. IP address is an array of 4 bytes. You know that each number in the IP is a 0 to 255, so 0 to FF. So it's 4 bytes array. And the last one is the LED for the Wi-Fi LED in the board. I set it up to turn green, turn yellow when it's done. So when I reset the board, I load the program. This is the result. So you have a working Wi-Fi right now and connected. Congratulations. You made your first program to connect to the Wi-Fi. So we're going to wrap it up right now. So congratulations. Use this. Learn this. In the next lesson, we're going to go a little bit deeper, okay? Ciao.